everybody, how's it going? So I have this this little Python. Oh, I didn't use that library. Sorry. Library here that what it does is it reads these ZST files. What those are is they're a form of compressed file that's designed to be streamed while being compressed. That kind of messed with my head, but it doesn't actually slow it down that much. So inside it is a JSON-L file where every line of the file is its own JSON object, and then Python just makes it trivial to just load it and go through. But there is an incredible amount of data in there. Let me bring it up. The compressed version is as you can see, it's 30 files. What am I doing here? And the size of the compressed versions is 425 gigabytes. So this is training data that's used for large language models. I believe this was used to train the Llama GPT, which is getting pretty close to competing with GPT 3.5. Not quite to GPT-4 levels yet, but you know, they don't have the funding, so what do you do? Anyways, I got off on a little bit of a side tangent. I'm not trying to train a large language model here. I just want to find out what tokens are used because I'm looking for sample sentences for my reading program, or not reading, my language learning program. I've swapped back and forth so many times now I can't even keep it straight. Now, this was just an experiment to see how fast it could read these files from my NVMe drive if I spun up 30 different processes. And it took about 12 minutes and returned the length accordingly. So that's good. Now you got to remember that a Python thread, at least using the standard Python library, won't actually execute in a different process, which means it won't actually utilize multiple cores on a CPU. If you want to do that, you have to spawn up a brand new entire process, which I'm aware it sucks. I know I'm not happy about it. I didn't design the library like that. I don't know what the hell they were thinking, but whatever. This is what we have to work with here. That might not actually be a consideration with PyPy, but just with the standard Python library, which happens to be what I'm using. So let's see here. What I'd like to do is I would like to go through and find out every token of characters that's the most common. And we'll get, like, I don't know, the top 2,000 or something. And then what I can do is I can look at a piece of text and I can figure out if any of the tokens in that piece of text don't match up with the top 2,000 most common characters. And if that's the case, then maybe it's not English, maybe it has rare words in it. Now, what I could do is I could say, all right, 95% of this string is the most common 2,000. It's not really a word, it's because like NT will become its own fragment, but you know, its own token. Let's call it a token. That sounds better. So let's start off first just seeing if we can collate this data in any form. So let's go. Well, first off, we need max lines, because this might take absolutely a ridiculous amount of time. So let's say max lines is 1,000, process file, decompress file, where is it? Where? Okay, this is where the lines are. I don't know why I was getting confused there. So lines, line red equals 0, lines red plus equals 1 if lines red is greater than or equal to max lines, then return what? Just return, that's all. just break. That's what I want. That's what I meant. Okay, so is this going to work, or does this need to be global? Let's see. 1. 1 sounds good. Now this should execute pretty fast. Still taking a little bit of time. I think just loading those files takes a while. Okay. I've confirmed that this is behaving more or less the way that I expected it to. Oh, that one's big. Alright. And go read 10, then I would expect this to get quite a bit bigger. But I don't expect it to take significantly longer to read. Okay, quite a bit bigger, executed in 5.5 seconds. Yeah. So this is good. We need to go through and we need to get the tokens now. And then we have to combine them together. The problem is it can get really, really big. So we're going to need a, what's it going to be? It's all tokens equals counter. And then, oh. Would have expected that to have already been in there. Okay, and then we'll say like every, I don't know, 100 lines or so. If lines read, you know what? Let's do it this way. And 127 equals 127. So that'll be like every 128. In that case, then all tokens equals all tokens dot most common. How many? Let's say 20,000. I think that that's overkill. Well, I might want the most common 10,000. And I mean, for the very, very most common, it probably wouldn't matter. But for the rare ones, it's possible that something from a different file could bump out something from the first file. And I don't want to discard stuff that might be important. So this is what we're doing. Okay, let's say max lines equals 128, because I actually want to see that work. Decompress file, and then we're going to have to write this data to a file, and I always forget the format, so we're going to copy it from down here. Okay. Now it's not going to be file size anymore. This should probably be configurable. Oh, well, whatever. Okay, no, that's not what I wanted. Where are you? Okay, is this receiving a file name? It is. So we're going to say data. Oh. Yeah, we want file name fragment equals file name dot split. I'm using forward slashes, right? And then we want the last piece, file name dot split file name fragment. That's interesting. Fragment. Let's see what we do here. And then it's not going to be data, it's going to be all tokens. And then we want to make this pretty, right? So indent equals 4. And should that work? Well, it should work, except I'm not actually passing the data out. All right. X equals x dot lower. Is there a way to split on every character that doesn't match? X dot split. It's already a string, but I want the IDE to know that it's a string. So we're going to have split, separator, max split, characters, iterable. Okay, so basically nothing. We're going to say character mapping def cm. Basically, everything is going to be a space unless it's an alphabetical character. So if s dot is alpha, then return s, else return. I've done this before, and it's actually pretty damn slow. I should probably be using C or something, but I don't know how to get the data out of the ZST into a format that C can read and then back into Python. It's a pain in the ass, so I just upgraded my processor instead. So let's see, x equals str x dot lower, and then x dot join. Do we need to do that? No, this is what I meant to do. Join cm of I for I in x. Okay, that should work. And then we're going to say x dot split on space. No, x equals x dot split. For character. Okay. My count equals counter x dot split. That should do that. I for I in x dot split if I. We don't want any empties. What is this angry about? Shadows from outer scope. I don't care. Okay, this is not the ideal way to do this because it'll recreate the object, but I just want to see if it's working. So where is do it? Do it. It's right here. So we're going to say all tokens equals, no, let's just do it right. For kv in doit.items, we'll say all tokens of k equals all tokens of k plus v. There, then we've done it right and we don't have to rewrite it. I don't know why I didn't just do that the first time. Now let's see. Now if we're actually doing something with the data rather than just getting the size, I expect it to take significantly longer, but I don't know, maybe it's more limited by the I/O than I thought. Oh, we have really pissed it off. List indices must be integers or slices, not strings. All tokens. List indice. It's not supposed to be a list. It thinks all tokens is a list. Most common returns a counter, right? No, it returns a list of tuples. Well, shit. Okay, we'll have to figure that out. Alright. That did not take very long. 5.734 seconds. I do have a pretty good processor, so, you know, maybe. Here we go. Probably shouldn't have put this in the main. That's expected, and of a 2 in But, oh, I did trim it at the end. So yeah, Piri, Wu Sungbi, Zetrans, Ermanes. You know what? Maybe we don't need 20,000. Now, my initial, just what my gut was saying was first 2,000. So, Dusk, BC, Sumptuous, Cocktails. You know what? This runs fast enough. Let's just switch this to 2,000 and see what it gives us. It should still take about 6 seconds, I guess. Alright, and let's see. Controlled, cancer, estimates, measurements, proportional. These are less common. I wonder... Safety, intensive, resistance. I wonder if we go to right about the middle, if it's about the same. Maybe we don't even need to look at every single file for these general statistics. Store, about line 4,000, right? Store. What? Well, you know what? I did say max lines equals 128. So maybe... If I multiply this by 100, this should multiply by 100 too. Let's do 10. I can wait 50 seconds. Let me look at my processor here. What the hell? Okay, I was expecting more of a delay than that. Maybe most of the delay time is just loading the damn library or something. Or maybe there's a lot of overhead with initially opening the file. Okay, around line 4,000 is forward. That's in number 2. And, okay, well, not exactly, but, you know, pretty close. Forward, let's look at one more. Okay, further down. If I look at every file, then I think I am going to need to figure out a way to trim that. So I wish that there were a way to filter it more easily. Well, it's recreating the object that I don't want to do, but I might not have a choice. All tokens dot most common. Is this going to work? I mean, that would make my life so much easier if that just worked. Now, we understand that we're going to lose things around the edges, but that's okay, because we don't look around the edges. I'm not looking for the 18,000th token. I just don't want to lose a count of something. Looks like it worked. So, okay. I guess I'm done whining then. In that case, I guess I could just type infinity. Let's let's see what it does. I don't plan on leaving the video running, that's for sure. I will need to create something to collate this. All right. Well, that should be pretty easy. Okay, read every ZST file. New name, collate data from read all. What a terrible name. Okay, we're going to say for I in range 100 to 130. And then file name equals, what am I doing here? Let's see if we can get this. No, don't move. Paste. And str of I starting at the first index, print fn. What did I do? urun. Okay, those look like the right file names. Let's see if we can load. Load file name. I don't know why I did it like that. Print length of loaded data. Let's see if it works. 20,000. All right. This might be easier than I thought. C equals counter. There we're going to say C equals C plus counter of loaded data. Then C equals C dot most common. 20. Let's just do 10. Print C. What did I do? Unhashable type list. List. So it's a list. I don't want it to hash the list. Counter of, I don't know, dictionary, I guess, C, comma, V for C, comma, V in loaded data. You're going to do what I want? You're going to be a little hoe. Well, I think it answered my question. Unhashable type list. I don't want it to hash. There's 20,000 items. Each one of those is a list. Print loaded data 0. Let's see what we're looking at here. Okay. Really? Man, it must be because the sample size is so low. So, each one of these is going to be an array. So we're going to say ARR0, ARR1. Please work. You're starting to piss me off. What is a list? For ARR in loaded data. Print ARR. What in the hell? Six one. What is going on? Print type of ARR. Class list. Print ARR of 1. I don't know what the hell's going on here. List of a list of a list of a list. Okay, that's what I was expecting. What was that thing before? Well, now I'm curious what... Okay, for ARR in loaded data. ARR 0, that's the word, which is the key. ARR 1. Unhashable type list. Okay. For ARR in loaded data. ARR 0 equal, no. Key equals ARR 0, val equals ARR 1. Assert type of key equals type of hello. And then type of val equals type of 1. Then C of key equals C of key plus C, no, plus val. Assertion error. Type of key. Class list. Something is very, very, very wrong. And I probably shouldn't record myself trying to figure it out. Close U. Of course this isn't finished yet. Alright. I have no idea how long this will take. I mean, it might take many hours. I have no idea. It takes 11 minutes just to read the data, but then actually parsing, it's like over a terabyte of text. So I'm just hoping that the multi-processing, splitting it up between, 30 processes is going to speed it up. So yeah, I'm trying to utilize my 32-core processor that I got. It's the Ryzen 9 7950X 3DS. I don't think I actually needed the 3D thing because I'm not using the integrated graphics chip, but whatever. That's the one that I got, and so everybody's happy.